Hi, my name is Jessica Chao, and this is the final demo for my senior project, Greenbin. So, what's Greenbin? Greenbin is an iteration of an ongoing project led by Dr. Tolly Freed in an effort to reduce consumer landfill waste. Currently, there are approximately 1,000 disposable food containers going to landfill daily by campus dining. We're trying to decrease the number to near zero. Greenbin is a system that keeps track of RFID tagged containers checked out by students. It sends information to a remote database server and keeps a history of past transactions. It is a passive RFID reading system that scans containers and sends it to the database. The current implemented features are checkout of containers, the return of containers, information search of checked out containers, and a history search of past transactions. Additionally, there is remote connectivity via a cellular network, as well as the backup of data in case of network failures. So the system has several components. In the first picture shows a hat board with a Raspberry Pi 2 underneath. The hat board connects to an LED output and button board that signals when a read has been made. The USB ports hold an AnyWish Wi-Fi connector and a mouse and keyboard in order to take in user input as well as connect to the database. Underneath that is the ThingMagic M6E development board, which connects to a SAMSys antenna that picks up tags. So here's a setup of how it actually works. This is a container with an RFID tag in there that I stuck in. I'm going to put that in front of the antenna. And I'm going to press this button, which will pretty much pick up the tag and output it to a text file onto the Raspberry Pi. Here I'm connecting my Raspberry Pi to my mobile device, which is my phone's hotspot. I just named it after my name. Now I'm going to use this bash file that I wrote called openrftag, which pretty much runs the system. Here I am inputting my host computer's IP address so that it could connect to the database. This is the add container function, and it outputs a success message once it has been added to the database. Here's the MySQL database. Before, the container table was empty, but after the add container function, it has now added an entry into the table. Next is the checkout container function. It's the same as the last demo, where I pretty much have a checkout form where students can fill out their first name, last name, and poly ID number. After submitting that, it should update the table called checkout in the MySQL database. And here it outputs a success message as well. So after running select from checkout, my table has been updated in the database. Here's the information search form where you can search up information from the database. I put in my student ID number and it outputs a query with my poly ID, GTIN, serial number, checkout date, and checkout time. As you can see, it's the exact same output from the MySQL database table. A new feature that I added since the last demo is this history button, which pretty much searches for information after a student has returned an item. So here I'm searching for my ID, but the query won't show anything because I haven't returned anything yet. But after returning the container that I checked out, it should update the history table. So here I clicked return, and it takes in the container that was scanned in and deletes it from the checkout table and adds it to the history table. So you can also search up information from the history table of past transactions. Let's search up 2017 May 7th. And then it outputs information about who checked out a container on May 7th, 2017. Finally, delete container deletes the red tag from the file from the database and outputs a success message that says that you've deleted the container. And here I'm just checking on the MySQL database that the container has been deleted from the table. I mentioned this before, but the system also has a backup capability, which pretty much runs in the background when you're executing functions while the system is running. Each statement is written to a backup file, so if a network failure ever happens, you can rerun those statements and into MySQL. There are some remaining limitations for this system. Testing of 10 duplicated systems to one server has not been tested yet. Additionally, there is a 37-second read delay to output tags to a file. This is due to the underlying software on the ThingMagic M6E development board. Additionally, there are no refund functionalities as well as no access to the real Polycard database due to security reasons. Some future work could also be done on the collection bin side of this system. When a smart collection bin locks the return function when network failures happen. Additionally, a faster read time is necessary to ensure that long lines during meal times are not delayed longer than needed from RFID tags needing to be read.